Mahdi Azizian. Today I'm going to talk about our journey from surgical co-pilots to physical AI and how we can build that on top of the NVIDIA HoloScan platform. The agenda is simple. We go through an intro of NVIDIA HoloScan. We talk about surgical co-pilots in general and how we could move toward physical AI for surgery. So NVIDIA HoloScan is a real-time AI sensor processing platform. Mainly, it is meant to bring an all-in-one production-ready platform that actually solves the guarantee of performance and usability for medical device companies to build products on top of. It's meant to let you create this cycle of going from sensing to thinking to action and closing the loop in real time. A flattened version of the circle can be seen here, where you can actually bring sensor data in real time to GPU memory, do processing with AI and Gen AI, and then going to visualization, analytics, and action from there. A reference application in cardiac ultrasound is shown here, how you can go from all the way of RF ultrasound to insights from that. And this platform actually would let you have an optimal pathway of as low as 10 milliseconds from photon to glass, running 30 plus AI applications on the edge in parallel, or 70 billion plus parameters of large multimodal models on the edge. And this would allow coexistence of different software as medical devices, as you can think, on the edge. With different backends, and there are a lot of reference applications, 70 plus of those on HoloHub. You can look at the barcode below. To streamline the concept of a medical device into a production unit, you want to bring your own sensors, bring your own models. You want to build your own applications, and HoloScan Sensor Bridge and HoloScan SDK provide that. And then you want to test and validate. And NVIDIA IGX Dev Kit is a production equivalent dev kit that would let you go through tests and VMV, and then deploying at scale using the IGX production units that a lot of our partners are building. And then when you launch and maintain, NVIDIA AI Enterprise provides long-term software support and the cybersecurity guarantees that you need to put a medical device in the market. There is a wide range of compute available, obviously, on the edge. A production-ready dev kit would let you develop and test your software as medical devices. And then you can choose IGX from IGX 700 to 500 with different sizes and compute powers. And next year, there's a next generation of IGX Thor that is coming to market that you would be able to getting much more compute power on the edge. So with that intro, let's actually go to surgical co-pilots and see what can be done and what is the art of possible in this domain. You can think of the surgical co-pilot as an AI assistant that is running on the edge in the operating room and helping you as surgeon and clinical staff to basically answer your questions or take actions for you. It has all the context of electronic health records and PACS systems. It would bring other basically notes and plans and instructions in form of RAGs, and also even documentation of the medical devices in the operating room. And the live stream of data from endoscopy videos into alternative imaging modalities like ultrasound and fluoroscopy to, for example, kinematics and events from a robot, patient monitoring signals, room videos, and also information from preoperative scans of the patient could come in. And an agent framework would let you make calls to the right large multimodal models or VLMs or LLMs based on the query and the command that is coming from the surgeon. At GTC 2024 at March, we actually showed a version of that we developed with help from some of our partners, Active Surgical, Moon Surgicals, and others. Let's take a look and listen into what this provides. I don't know if you have the audio. Apparently not. I can keep talking while fixing the audio problem. So this is a co-pilot that is running and has coverage of basically 4 episodes of surgery, from a training and refresher of medical device products for the staff who want to learn or remind themselves how to work with, say, a surgical robot, to preoperative planning and intraoperative assistant, and all the way to taking case notes at the end of the surgery. So this is actually a recording of one of my colleagues of how basically he's communicating with this co-pilot, which has access to EHR packs and live stream of laparoscopic video for a lab cholecystectomy case. That's fine if the audio is not working. I can talk over it. That's okay. Okay, we'll skip the audio. There are actually low-hanging fruits out of this that could become products by some of our partners. David Noonan, session 11, is going to touch on how Moon is actually taking this into a medical device trainer that could help with the Maestro robots in the operating room. Or EHR agents, electronic health records basically being at the touch point for the surgeon in the operating room. This is a collaboration with one of our other partners that would come as a reference application on HoloHub pretty soon. In the preoperative planning phase, and in the co-pilot video, we showed that you can actually bring in, the co-pilot can pull in the PACS data for the patient, segment it, visualize it, and then interact with the visualization. But envision if you could actually have a radiologist AI assistant at your hand. That's why we're collaborating with East River Imaging and Mount Sinai, and with them providing 400,000 CT scans, MRIs, and PET scans of patients with associated radiology reports. We're training this radiology co-pilot where you can actually talk to this co-pilot about the conditions in the preoperative scan of the patient, for example, a tumor, potential diagnostics of that, and use that during operation. Obviously, this has broader use cases than surgery. The co-pilot that was shown in GTC, it was a fine-tuned lava model. A lot has changed since then. NVIDIA has released the VILA foundational model. That is a VLM, and by fine-tuning that for surgery, we actually have got much better results with the F1 scores, as you see with the surgical phase recognition, and also the surgical action triplet recognition. The two main things that probably help with this improvement is that VILA has much larger context and also can process a sequence of the frames, so has a better temporal visual understanding of what is happening in the surgery. So with all of that co-pilots, the actions are more like talking back to you when you're asking a question or taking a note or doing something like that in the background. But what if it could actually take a physical action? The era of physical AI is here, and things are moving very fast, especially with the push in humanoids. So take a look at what we showed at SIGGRAPH a month ago. Unfortunately, there's no audio here, so I'll talk over that. This is basically showing how we can teach by demonstration to the humanoids and create foundational models that actually can learn how to do things on their own. So our colleagues have basically used a augmented reality teleoperation system to teach different type of tasks and create few sample use cases basically for each of these tasks. And then using one of our NIMs, NVIDIA Inference Microservices called MimicGen, basically increasing the size of this data set by adding more synthetic data, and then using this concept of a tree computer approach, basically with AI training and simulation and deployment, and then closing the loop, basically improving this in such a way that the robot, the humanoid, in this case mostly for home assistant purposes, could actually prepare and do things on its own. These are moving at a very fast rate, as you're seeing 10 plus companies who are planning to go to production in the next few years. So expanding some of that work to surgery is something that we have been looking into. One of the papers the team has published at Ai2m in collaboration with Georgia Tech and Berkeley, it's called Sophia. This is actually going from language, basically verbal commands of the surgeon, to motion. And this, again, we don't have audio here. Let me quickly show how this might work. So basically, the surgeon talks to this co-pilot here, and the system at the same time is observing what is happening in either a digital or real environment, and recognizing basically the logic behind what the surgeon is asking and what is in the field. For example, the surgeon is asking to pick up the suture, by one of the arms that is closest to that and take it up and pass it over to the other arm. And basically this Copilot, this physical Copilot, will be able to do that for you. Obviously, this is more of blue sky, doesn't have direct application at the moment, but it's scratching the surface on what can actually physical AI bring to surgery. With that, an extension of that work of bringing behavior cloning to surgery as well is ongoing. We just submitted a paper to ICRA for 2025. This is actually building a surgical digital twin by bringing CT scans, real or synthetic. We have a model called Macy that generates a lot of synthetic preoperative data as well. Segmenting those and creating meshes that we bring into Omniverse that you can interact with. And using that, we can generate a lot of these teaching by demonstration policies and clone that behavior and expand the synthetic data to train surgical subtasks that can be done automatically, triggered by a surgeon command or in the context which the large language model understands. So with that, I think I can wrap up the talk. It was mainly showing the art of possible. NVIDIA is not a medical device company, obviously. We try to show and inspire what can be done on top of NVIDIA platforms with AI and Gen AI.